Today, we're diving into something I think we've all been feeling: why our summer weather seems to be getting stuck. You know, those heat waves that just don't quit and droughts that just seem to drag on and on.
I mean, you know that feeling, right? When a heat wave rolls in and it just doesn't leave. Day after day, it's the same blazing sun, the same oppressive heat, and there's just no end in sight. It really does feel like the weather has just hit the pause button.
Well, it turns out you're not imagining things. That feeling is actually backed by some pretty serious science. There's a growing mountain of evidence that the atmosphere's entire circulation is, believe it or not, slowing down. And that's causing our weather to get way more persistent. It's not just getting hotter, it's literally getting stuck.
Now, to really understand what's happening, we first have to look at two things that are becoming a really dangerous combination: extreme heat and extreme dryness. Okay, so first things first, let's get our terms straight. A lot of people kind of use heat wave and drought to mean the same thing, but they are absolutely two different beasts that are now starting to work together as a dangerous team. A heat wave is all about temperature, a long stretch of really high temps. A drought, on the other hand, is fundamentally about a lack of water. And when they do team up, scientists have a special name for it: a compound hazard. This isn't just a simple case of 1 + 1 = 2. Oh no. This is when two totally separate dangers crash into each other and create this feedback loop that makes both of them so much worse than they'd ever be on their own. And here's exactly how that nasty feedback loop works. A heat wave comes in and just bakes the ground, right? That cranks up evaporation and makes a drought worse. But if a drought is already there, it means there's less moisture in the soil to evaporate in the first place. So all that sun's energy, instead of being used for evaporation, goes directly into heating the air. And that makes the heat wave even more intense. It's a truly vicious cycle.
You can actually see how this plays out, kind of like a set of dominoes. It all starts pretty simply with what's called a meteorological drought. Basically, it just hasn't rained enough. That's the first domino. Then you add high heat to the mix, and boom, the second domino falls: agricultural drought. The soil dries up and crops get really stressed. And if that keeps going, you get the third domino: hydrological drought. That's when our rivers, our streams, and our reservoirs start running dangerously low. One thing leads right to the next.
So we've got these intense local feedback loops, but what's causing them to get locked in place to begin with? Well, for that, we need to zoom way, way out and look at the bigger picture, high up in the atmosphere.
The reason these weather patterns get so stubborn, it isn't something that's happening on the ground. The real answer is hidden in those vast, planet-sized currents of air circling the globe, the very engine that drives our entire weather system.
And the main finding from all the latest research is frankly pretty startling: that massive global circulation is actually slowing down, especially during the summer. You know, the winds that are supposed to move weather systems along, they're losing their punch, which allows these systems to just sit there and linger. So how in the world do scientists even visualize something like this? They use a tool that creates this kind of map of all the possible states the weather could be in. What you're looking at is called a Lorenz attractor. Think of each one of those lines as a potential path the weather can take. What scientists are seeing is that the system is taking fewer and fewer of these paths. It's becoming less creative, more repetitive, and a whole lot more likely to get stuck in a rut. Now, there's an official scientific term for this phenomenon of weather getting stuck. It's called weather persistence. And it's a direct measurement of how long the atmosphere tends to stay in a similar state. So when persistence goes up, it means those long, drawn-out heat waves and stagnant, boring weather patterns become way more common. And look, this isn't just some new theory. After analyzing 40 years of data, scientists found a clear, statistically significant increase in this summer weather persistence. It is a documented, long-term trend. Our weather is, objectively, losing its momentum.
But how can they be so sure? Well, it really comes down to upgrading their tools so they can measure these incredibly complex, interconnected systems with a lot more accuracy. A huge part of this breakthrough actually comes from just upgrading the tools we use. See, in the past, a key indicator for drought, the SPI, only looked at one thing: a lack of rain. But that's only half the story, right? The newer indicators, things like SPEI and SMI, are so much more powerful because they look at everything. They integrate temperature, the rate of evaporation, and the actual moisture in the soil. They're measuring the whole system, not just one little piece of it. As the researchers from the SEMA Research Foundation put it so well, if you only focus on rainfall,
you would miss half the picture. Heat is such a critical part of this equation, and these new tools are finally letting us see the full, devastating impact of these compound hazards.
So, what does this all add up to? Well, it points to a really fundamental shift, not just in how intense our weather is, but in its very behavior, its whole rhythm. Okay, so let's tie this all together. We've seen how heat and drought aren't these separate problems anymore. They're teaming up in this dangerous feedback loop. And the big reason they're able to do so much damage is because the very engine of our weather, that global air circulation, is slowing down in the summer. This weather persistence means we're not just getting more heat, we're getting a fundamental change in the rules of the game. Ultimately, we have built our entire world around a climate that has a reliable rhythm, a system that we could count on to change, to shift, to move on. The science is forcing us to ask a really profound question. What happens when our climate starts to forget how?